Well, how do you know that the law of sines even works? I mean, who came up with this formula, and how do they know that it's true? Well, in math, you have to prove things in order to make sure that they're true. You can have a good idea about something, but until it's been proven, we really can't accept it as truth. So we're going to prove the law of sines. So we'll start with that picture. It's just a generic triangle like we started with, capital A, B, and C, lowercase a, b, and c. And you can do this. Draw an arbitrary line. We're going to draw this right here. When we draw that, we're going to ensure that it makes a right angle. And we'll call it something else. We'll call it, oh gosh, I don't know what the next letter is. Oh yeah, I'll just use D. Okay, that's going to come in handy in just a minute. Now, knowing that the law of sines is true, we're going to aim towards that. We're going to try to get this. Now, we know it's true because it's been proven. So, knowing the formula we're aiming for, we're about to prove what we already know is true. Here's the reason we're doing it. Mathematical proof has been used for centuries, centuries and centuries, as a way to refine people's arguments. Abraham Lincoln was an incredible, incredible lawyer because he would go through mathematical arguments and refine his arguments based on little truths, and he would piece together everything he was going to say based on smaller truths, and that's what we're about to do. If that made no sense, it's okay. By the way, just while we're on it, Abraham Lincoln, when he was a child or a teenager, I don't know the exact age, but he got a hold of a book called Euclid's Elements. It's one of the oldest math books, and it deals with mathematical proof. And that really helped refine his lawyer skills. But the cool thing, Euclid's Elements is the second best-selling book in the world behind the Bible. So the second highest-selling book in the world is a math book. Ha! Isn't that cool? You probably don't think so, but I do. Okay, here's what we're going to do. We've split this triangle up into two pieces, and we're going to do a little bit of right triangle trigonometry because we have a right angle now. So I'm going to grab a Post-it note. I'm going to slap this down. I'm going to cover it up. Okay, let's draw some stuff. Knowing that I'm dealing with the law of sines, let's write down some stuff. The sine of angle A. This is going to start looking familiar. This is opposite over hypotenuse. This is opposite right here, and we know what it is. It's D. So opposite over, well, the hypotenuse in this case is B. Okay? See that? Sine of A, capital A, equals little d over little b. And that's based on this triangle. Well, you know what? We can do some other fantastic stuff. Let's slide the Post-it notes over. I'm going to write this one over here. The sine of big B is equal to, well, opposite, D, over hypotenuse, A. There we go. Okay, you're probably like, where in the world are you going with this? That's exactly where I'm going. I'm about to prove that this thing works using mathematical arguments. Let's do some cool stuff here. Perfectly legal. If I was going to solve this for D, I would multiply by B. You can think of this as cross-multiplying if you like, but I'm just going to multiply by B. And in multiplying by B, they're going to cancel out right there. And on this side, I'm going to have D equals B times the sine of A. Let's keep these separate. Now I'm going to do the same thing here. Let's multiply this one by A, and these will cancel. And we'll multiply this one by A, which means that D is equal to A times the sine of B. Okay, I know that looks like a big jumbled mess, but I want to point out something. If all this mess is equal to D, and all this other mess is equal to D, then these two things must be equal to each other. If Bob is the same height as Charlie and Charlie's the same height as Dennis, then Bob is the same height as Dennis, right? So if this is D and this is D, then these are the same. So we're going to come down here in a different color. We're going to write that out. B sine A equals A sine B. Ha-ha! We're about to turn this into this. Let's do it. Let's divide by B. It cancels those. And we're left with sine of A equals A sine B over B. Now, let's also do this. Let's divide by A. It's going to cancel those. And I want you to realize what you have left. You have sine of A over A. See? You have sine of B over B. Boom. We just proved the law of sines. It's one of those neat little things I just wanted to show you for the sake of argument. You never know when you'll see it again.